Hello everyone, welcome back to the channel. Today we are going to discuss this problem. It is regarding the chapter of thermodynamics. Right, so let's go through it. We are given two reactions. In first reaction, the boron is heated in the presence of oxygen and it is giving us B2O3. As we can see, the delta H is negative, therefore first reaction is exothermic in nature. In second reaction, boron is heated with hydrogen to form B2H6 and this reaction is endothermic because delta H is positive. Now, if the container contains both O2 and hydrogen and it is totally isolated from the surrounding, the container is totally isolated from the surrounding, we need to find the molar ratio of O2 and H2 so that the temperature of the container do not change. Now, two things are there which we need to understand in this question. One thing is that first reaction which is taking place is exothermic and second reaction is endothermic, right? And most importantly, the temperature of the reactant, the temperature of the reactor or the container is not changing. That means whatever heat is coming out from the first reaction is getting utilized in the second reaction. That is how we can infer, right? Because otherwise, if there is any change in the heat, there will be change in the temperature. So we can use this method to find the ratio of O2 and H2 in the container which is getting utilized in both reactions. Now, in the first case, in the first reaction, if we see minus 1260 kilojoule of heat is released when excess of boron reacts with 3 by 2 moles of oxygen. So we can say that, see, for the first reaction, minus 1260 kilojoule of heat is released. But for the second reaction, how much it is required? It is 30 kilojoule. So we can say that 1260 kilojoule of heat is released when 3 by 2 O2 moles are utilized, right? When 1260 kilojoule of heat is released, 3 by 2 O2 moles are used. And if 30 kilojoule heat is there, then how many moles of O2 will be required? So it will be 3 by 2 into 30 divided by 1260, right? So if we calculate it, it will come out to be 15 into 3 upon 1260, 15 upon 420, right? So this is the number of moles of O2 required for 30 kilojoule of heat production, right? Because this 30 kilojoule is required in the second reaction. And in the second reaction, if you see, for the requirement of 30 kilojoule of heat, how many moles of H2 are reacting? 3 millimoles, or we can say 3 moles. That means now if we have to find the ratio of H2 is to O2, it will be 3 is to 15 upon 420. So now multiply both sides by 420, it will be 3 to 420 is to 15. Upon solving it, it will come out to be 84 is to 1. So this is the ratio of H2 is to O2 which reacts in this container with boron. So the answer will be option D, right? Because we have found H2 is to O2 which is 84 is to 1, but in the question it is asking O2 is to H2. So that's why it is 1 is to 84. So that is how we solve this problem. So this question requires the basic understanding of heat balancing, right? Also, the most important crux of this question, that the temperature of the container doesn't change. I hope you understood this problem. For more problems, stay tuned. Have a good day.